Hello, everybody. Welcome back to Math 100. This is section 3.4, perhaps the most practical of all the sections you will learn. We will today be talking about buying homes and cars. It's about loans and mortgages, all right? I am going to give you some ideas to save tens of, maybe hundreds of thousands of dollars in your lifetime. Let's get started. Okay, section 3.4 is about loans and mortgages. What in the world is a mortgage? Okay, this T, by the way, is often silent, so you will not hear people say mortgage, but mortgage. Okay, now mort sounds like mortuary or mort something, and so M-O-R-T is a Latin prefix meaning death. All right, so mortgage in the original term meant death pledge, like I will bet my life on this, right? And so mortgage today in this context of finance means a long-term loan to be paid back by a series of equal payments. All right, so loans and mortgages are essentially the same thing, governed by the same mathematics. All right, mortgages tend to be for larger amounts and for longer periods of time, but these are just types of loans. All right, so really this section is about loans. Most of us will borrow money in our life. If you have not yet, you probably will very soon. Okay, student loan is a type of loans, of course, a mortgage for your house or loans for your cars or loans on your credit card. Those are also loans. Okay, so this particular section is probably applicable to all of us. I can't imagine that a person should be a college graduate or have a degree or even just live in this society, our advanced society of finance, without knowing anything about loans and mortgages and how they work. All right, so this is very important. I want you to really get the basic ideas here. And once again, the calculations will become complicated like this and it gets worse, but that's okay. Remember, I want you to get a big picture, and the most complicated formulas are the ones that you do not have to memorize, okay? Now, recall that the money amount today depends on, how much it's worth today, but it's different from how much it's going to worth in the future because money, the value of money is time sensitive. This, as I said before, is probably the most important concept in chapter 3. Money grows. Okay, not just because you can put that in an account, but people can invest the money that you invest into a bank and so on. All right, so money inherently has that investment or money making, reproducing power, and because of that, money is time sensitive, and that's where we have a saying, time is money. When moving money forward, remember we moved the money forward and we had formulas like this. We had the P0, I guess P naught. This was our principal. And then this was one of the first formulas we learned. K is the number of compounding periods per year. R over K is the rate per period, remember? And actually, I'm going to make this a little change here. This used to be N times K up until the last edition. In our new edition of the book, we call that N T. T is the number of years. Okay, T is time in number of years. So 1 plus R over K raised to the KT, where the KT represents a total number of compounding periods. Okay, this is our compound interest formula. But when you move the money backwards, not surprisingly, we go this way. And the way we do that is we are not going to multiply by this, but we divide by it. And one way to algebraically describe that going back or dividing by that factor is to put the negative sign here. So it's negative KT. Okay, sorry about that. Maybe I should write this over here. What we are saying is the amount in the past is the principal times, principal times 1 plus the rate per period, which is R over K, and then minus KT. Okay, that's how you move the money backwards at R as the interest rate, K as the number of compounding periods, T is the number of years. All right, so with that, let me explain what I mean by that. Suppose on January 1st, okay, so beginning of the year, you just happen to have some need. You agree to make 12 payments of $100 at the end of each month. Okay, so you go to your friend and you say, look, I need some money right now. I don't have the money to pay my rent or whatever. I'll make a payment for something, pay the bills. And so, look, I am going to work, and at the end of every month for the next 12 months, I'm going to pay you $100. Okay, so can you let me borrow $1,200? And your friend should say no. Okay, because again, the amount of money you can borrow today is not how much you can pay over the next 12 months. Okay, how much can you borrow today according to the calculations of compound interest? Let's say the interest rate is 12%. That's a very high interest rate, compounded monthly. By the way, as you know, this means what? It means 1% each month, right? That's what makes it 12% compounded monthly. So the answer is not 1,200. It's not the sum of all your future payments. What you have to do is, here's your $100 you're going to pay back in a month. You have to bring it back to today. Here's $100 you pay in 2 months. You have to bring it back today, which is not worth $100. It's less than that. And so you do that with all 12 of these payments, and then you add this. This is the sum of the future values. Sorry, the sum of the present values of all your future payments. That's how we calculate how much your loan is worth. All right. So today, the $100 you pay on January 31, that's a month later, it's going to worth 100 times 1 plus R over K minus 1. Okay, why? Well, because, oh, sorry, I think I have a specific number here. All right, so R is 12. And K is 12 because it's each month. So R over K is 1. It's 1%, sorry, 1% per period. Okay, so the answer to this question is actually 1.01, or rather 100 divided by 1.01. And you can write that 100 divided by 1.01 because you're moving the money backwards. You can write that as 100 times 1.01 to the negative first power. Okay, if you really want to know what that is, it's 100 divided by 1.01. So instead of multiplying moving forward, you are dividing, which moves the money backwards. Now, your second payment is going to be made at the end of your second month, February. Today, the $100 you will be paying back that day is not worth $100, but it's 100 times 1.01 to the negative 2. That's this amount brought back. And then all the way to December 31st, that is 12 months in the future. And so this is how much it's going to worth, okay? And then you have to add them all up. Okay, that's what you have to do to find out how much you can borrow today. Okay, I hope you get the idea here. So $100 you pay a month from now, okay, and you can do this calculation on your own. You may want to verify this on your own calculator. That future amount of $100 in the month is today worth $99.01. This is called the present value of the $100 payment you are going to make a month from today. For the second payment, it's worth $98.03. That is the present value of your second payment of $100 to be made 2 months from today. The $100 you're going to make 12 months from today, that's not worth 100. In fact, it's not even worth $90. It's $88.74. Okay, 7475. And then you add up, well, not these, but then you have like 9 other payments, or the present values of payments in the future. If you add up all of these 12 payments, that's how much you can borrow today. All right, you understand that? Okay, you don't have to know all the details of the calculations. I do want you to know though, how the banks and other institutions calculate how much you can borrow today based on your future payments and the number of years, which is called the terms. All right, so here's a picture that helps you understand this, I think. All right, so here is now. This is when you need to pay now. Okay, so when you buy a car, you can say you are going to pay in the future, maybe for the next 5 years, but the money that you have to pay for the car has to be today. All right, so January 31st, February 28th, March 31st, okay, all the way to December 31st. You're making 12 payments. What I am saying is $100 that you're going to make a month from now is only worth 99.01. The second month you're making $100 payment. Yeah, that's only going to worth 98.03. Do I have the amount for the third? Yeah, the third payment to be paid at the end of March is only worth 97.06, and so on. The last one here, the last payment is worth, what did I say? 88.74, right? You add up all of these 12 present values. The sum of all of these is how much you can borrow today. That is the amount of your loan. Did you get that? More than anything else, like formulas, I want you to understand this concept. How do they decide how much you can borrow? Okay, the math is this. It's not that difficult, although the formula could look pretty complicated. So you remember the formula when you start to set up, amounts in the future. This amount, this amount, this amount, and they all earn the interest at the same percent rate, but different periods of time. Now you're going backwards. So pretty much everything is the same. P in this case is the, of course, that's principal. In light of, or in the context of mortgages and loans, this is also called the present value. How much is the total present value of all your future payment? That's nice because they both start with a P. So we can use P, capital P, to represent the amount you can borrow today. And here's the formula. Now, again, I do not have the the time or the mathematical, the method. I don't have the time to present to you all the concepts in mathematics, some advanced mathematics, to show you where this formula comes from. But it looks very much like that. Let me explain what I mean by that. You will have that 1 plus R over K. This is 1 plus the rate per period. And instead of multiplying it by K to the KTth power, we multiply you take it to the power of negative KT. That is the how you move the money backwards. And I used to subtract 1 here like this. We don't do that. Now we do 1 minus this, because this number will actually be less than 1. And then you divide it by, as before, R over K. Now this is a big expression, okay? But it's very similar to what you learned back in section 3. And this is a formula for calculating how much money you can borrow today, capital P, the principal or the present value. D is, of course, the amount of each payment. That's assumed to be equal for each period. And R is your APR. Okay, and this principle and this formula applies whether it's credit card loans or student loans or car loans, auto loans, or your home loans, which are called mortgages. Okay, let me explain by using an example. Let's say you can afford $200 monthly payment for the next 5 years. You're interested in buying a car. You show up to buy a car, smiling salespeople come, and one of the first things they will say is, so what do you do? And if you say you're a student, they say, okay, come back when you find a job. No, not really. What they're really interested in is, hey, how much can you afford to pay? If it's a 5-year loan, that's pretty typical for a new car, right? And the interest rate could be as high as 6%. It depends on your credit history. It could be even more, okay? But many auto companies will offer you like, well, sometimes 0% for the first few years, or 2% or 3%, but it could be just like 6%. 6% monthly, that means R is 0.06. Because it's monthly, you pay every month and your K is 12. And of course, the rate per period is 0.5%, which you can write as 0.005. That's this R divided by K. We've seen this number before. All right, so just using the formula, we can calculate almost immediately how much money you can borrow. By the way, the amount, oh, you know what? I will do this later because it's going to be right here. But the amount of money that you can borrow today is going to be $200 times, now this is going to be a big portion, which I, of course, encourage you to calculate first. 1 plus R over K minus, in fact, let's go ahead and write this down, okay, because you are given the numbers, okay? Why not use these numbers? All right, so this is 0.06 divided by 12, and then you raise it to the negative 12 times 5. That's negative 60th power. And then you divide it by this number 0.005 again, all right? And so maybe I can rewrite this to make it a little simpler. 1 minus 1.005 to the negative 60th power, all over 0.005. All right, I will show you how to do this on the calculator. Okay, so you may be seeing a little bigger calculator this time. I hope you are. All right, so for random R, you put the R, 0.06 divided by 12. In this case, it's going to be 0.005. Add 1 to it. This is 1 plus the rate per period. Now you raise it to the negative 60th. The entering of a negative number is somewhat different depending on what calculator you have. This particular calculator has this button plus minus. So you enter 60 and then you follow it by this negative positive. This will alter the sign. This will change the sign in front of the number. So what I'm going to do is I'm going to take this raised to the power of, raise 1.005 to the power of 60. Now I know it's not 60, it's negative 60. So I put 60 and then you put plus or minus. Many of your scientific calculators will have this negative or plus or minus sign that you enter after the 60. Some of your calculators, however, requires you to enter the negative sign before 60. So know your calculator. I cannot tell you which one to do. It depends on how your calculator is programmed. Okay, so what I will do here is this is 1.005 raised to the negative 60th power. All right, now what I have to do is to do 1 minus this, okay? Now, 1 minus this number is going to be 1 minus, but I can't enter this again. So I have a little trick here. I just subtract 1. I will show you how to do this in another way. If I do 1.005 raised to the negative 60th power minus 1, I get a negative sign, right? But that's the opposite of what I need for the numerator. So then I can get rid of that sign by entering that plus or minus, okay? 0.2586. That is how much, that's the value on the top of this, fraction. You divide that by 0.005, and that's what you will get. And this is inside of the big parentheses. And then you multiply this by 200, and you get this number, 10,345.11. And that is how much money you can borrow today. Okay, so make sure you can do this on your calculator.